Okay, so actually from the last chapter, what we did, it doesn't matter that how what concepts are going on. One concept will be taken, that is the mole concept and the and the concentration terms. These two things needed. Otherwise, nothing other things needed. Okay, concentration terms that they actually they that two are general topics. Okay, they that will require for every chapter. Okay, for everything. How to calculate moles and how to calculate the how to calculate the concentration, so that you need every time. Clear? Okay. So today we are going to start about electrochemistry. So in grade 11, you learn about redox reaction, right? Okay, you learned about redox reaction. So we will start from the beginning of recapping redox reaction. Okay, redox reaction. So today we will learn that thing. First, you have to understand what is redox reaction. Any idea about redox reaction? Do you have any idea about redox reaction?
Reaction is undergoes both reduction and oxidation takes place.
Okay, oxidation. What is oxidation?
Gain of oxygen or loss of electrons or loss of hydrogen.
Anything else? Anything else? Okay, so first understood what is oxidation. So oxidation means, oxidation name O is there, that means gain of oxygen. Okay, gain of oxygen or loss of hydrogen. Any reaction where there will be gain of oxygen is there or loss of hydrogen is there, it's called as an oxidation. Okay, or loss of electron is there, then also known as oxidation. Understood? Anywhere there is loss of electron is there, then also known as oxidation. And one more thing, remember, if increase in oxidation state, increase in oxidation state, then also it is known as oxidation. Okay, increase in oxidation state also known as oxidation. Now coming to reduction. What is reduction? Same, like exactly opposite of oxidation. Okay, what is reduction? Exactly opposite of oxidation. That means that means what? Gain of oxygen. So here loss of oxygen will be there. Here loss of oxygen will be there. Next, next loss of hydrogen. So there will be gain of hydrogen. Next, loss of electron. That means there will be gain of electron. And in case of reduction, what will happen? Decrease in oxidation state will be there. Clear? Decrease in oxidation state is there. Okay. For example, if I ask you that there is a reaction given copper plus oxygen gives copper oxide. Okay. Now you have to tell me which one is reduction reaction, which one is oxidation reaction. Tell me which one is reduction and which one is oxidation.
Cu to Cu is oxidation.
So here you can see that copper is getting one oxygen. Yes or no? So copper to copper oxide is oxidation. Clear or not?
Yes, sir.
And oxygen also losing one oxygen. So oxygen to one, this also reduction. Clear? Clear or not?
Yes.
Similarly, if I give you another question, that copper oxide is there. Again, when it will react with hydrogen, it will give copper plus H2. Clear? So tell me again, which one oxidation, which one reduction?
CuO to Cu is reduction.
CuO2 copper is reduction. Yes or no? Removal of oxygen. And
Yes, sir.
hydrogen to water, this will be oxidation. Okay, easy. Addition of oxygen. Clear or not? Sarvesh understood this thing?
Yes, sir.
Okay. So what is redox reaction? Redox means where those reaction in which oxidation and reduction both both happens simultaneously. Simultaneously. Clear? Clear
Yes,
this thing?
sir.
Now, apart from oxidation and reduction, how to remember also, I am telling you a trick. If you forgot sometimes you will forget that how to remember with respect to electron. Okay, like if I ask you sodium to sodium plus by losing one electron. So this is oxidation or reduction.
Oxidation.
This is oxidation. Okay, and if I tell chlorine will take one electron and become chlorine minus. So this is reduction. Okay. So how to remember this? Remember oil rig. Oil rig. Oxidation involve loss of electron and reduction involve gain of electron. Clear? Oxidation involve loss of electron and reduction involves gain of electron. Like this, you should remember. Okay. Now, there are two more things you have to understand. One is called oxidizing agent. One is called oxidizing agent or oxidant. Oxidant. Now, what do you mean by oxidizing agent or oxidant? First understood what is this. Oxidizing agent means who will do the oxidation. Means, see, oxidation means gain of oxygen, loss of hydrogen, loss of electron, and increase in oxidation state. Means who will be oxidizing agent? Who gives oxygen or who gives hydrogen or who gives electron. Understood? Who have the oxygen, they will give the oxygen. Yes or no? Yes or no? So it will act
Yes,
as
sir.
oxidant. Okay, so oxidizing agent means who gives who gives oxygen or who take hydrogen or who take electron. And one more thing, remember, who got reduced. Who got reduced. That is very important. By that you can understood what is oxidizing agent. Similarly, there is one thing called reducing agent. Reducing agent. Okay. Now, what is reducing agent then? Reducing agent or reductant. Reducing agent or reductant. What is reducing agent? Same is who gives hydrogen, yes or no, and who takes oxygen, and third one is who give electron, and fourth one is who got oxidants. Clear? Remember, remember this thing. In a reaction, oxidizing agent and reducing agent should be from reactant, not from product. Obviously, product are not giving and taking electrons. So tell me, in this reaction, which one is oxidizing agent and which one is reducing agent?
CuO is oxidizing agent.
Hmm. So CuO is oxidizing agent because it got reduced and because it is giving oxygen. So this is copper oxide will be oxidizing agent and hydrogen will be reducing agent. Clear?
Yes.
Clear. So if any reaction given, can you find out which one oxidizing agent and which one reducing agent?
Yes.
Now tell me one question. Noted? All this is noted.
Answer.
Done? Service understood? Any doubt till now?
No, sir.
Understood now? Okay. So, so I'm giving a reaction. You have to tell me that it is oxidation, which one is oxidation, which one reduction, and which one is oxidizing agent, and which one is reducing agent. Clear? So, reaction is iron plus sulfur giving iron sulfide. Then oxidation reaction, reducing reaction, and oxidizing agent, reducing agent. Now completely confused, huh? Sir, oxygen not there, hydrogen not there. How to find out? Right? Yes, sir. How to find out?
Trying with the oxidation states.
Do you know how to find out oxidation state?
For similar or familiar elements.
Okay, listen. So for this kind of reaction given, so we are unable to find out that how which on oxidation, which on reduction, because hydrogen, oxygen, nothing is there. Okay. So what to do? We have to go through oxidation state. So we have to understand what is oxidation state first. Oxidation state. Remember, oxidation state means the maximum number of electron shared or gain or loss by an atom of an element to make chemical bond. To make chemical bond. Clear? To make chemical bond. Clear this thing?
Yes.
Okay, so what is oxidation state? The maximum number of electrons shared or gained or lost by an atom, an element to make chemical bond. Now there are 5 rules I am telling. By that 5 rules, you can calculate oxidation state of any atom of an element. Okay, that 5 rules. Remember, first rule is rule number 1. Oxidation state of any free element, any element at its free state, any element at its free state will be 0. Like if I ask you oxidation state of helium, so 0. Oxidation state of lithium, free state, 0. Oxidation state of oxygen in O2, also 0. Okay, because O2, what is the free state of O2? What is the free state of oxygen? O2. So oxygen is 0. Similarly, N2 also 0. Similarly, hydrogen oxidation state in H2, 0. But if I ask you oxidation state of carbon dioxide, carbon in carbon dioxide, what will be the value? It will be 0 or not equal to 0? Not equal to 0. Clear? Oxidation state of carbon in carbon dioxide will be not equal to 0. Clear or not? Clear?
Yes.
Understood? So first rule is oxidation state of any element, oxidation state of any element in free state will be 0. Understood? Now, next point. Remember, next point. Rule number 2. Rule number 2 telling that oxidation state of group 1 element. Now, group 1 element means, which are group 1 element? Lithium, sodium, potassium, rubidium, cesium, francium. How to remember? Remember like this: little, naughty, kid, rub, cat's fur. Okay, remember like this. Okay, so all of them, listen, group 1 element, all of them, when they are combined to atom, or when they are in compound, understood? When they are in compound, the group 1 oxidation state will be +1. Clear? Always. In free state, it is 0. But when they're combined with any bond, then it will be +1. Understood this thing? Yes or no?
Yes, sir.
Okay. Sarvesh understood? Tell me yes or no. Tell. No.
Yes, sir.
Okay. Next, telling group 2 element. Group 2 element. Group 2 element means beryllium, magnesium. Okay. Beryllium, magnesium, calcium, strontium, barium, radium. How to remember? Best magician, best magician can strongly vanish rats. Okay. So group 2 element means these are beryllium, magnesium, okay, calcium, strontium, barium, radium. Okay. So when they are combined with something, then their oxidation state always +2. Clear? Clear or not?
Yes, sir.
Clear? And one more thing, remember, fluorine. Fluorine. Fluorine oxidation state always -1. Only fluorine. Chlorine, bromine, iodine, not. Okay. Chlorine, bromine, iodine, we have to calculate. Fluorine always oxidation state -1. Clear? This is the rule number 2. Understood or not?
Yes, sir.
Okay. When they are in combined state. Acha, if I ask you what is the oxidation state of fluorine in F2, what is the oxidation state? Tell.
0.
0. Understood? This thing understood or not?
Yes, sir.
So if I ask you what is the oxidation state of NaF, sodium oxidation state will be +1 and fluorine oxidation state will be -1. Understood? Yes or no?
Yes, sir.
So next is rule number 3. Rule number 3 told that oxidation state of hydrogen, okay, hydrogen when attached with non-metal, oxidation state of hydrogen will be +1. And when hydrogen attached with metal, oxidation state will be -1. Clear? Simple. Simple rule number 3. So if I ask you, like, what is the oxidation state of hydrogen in water? +1. And what is the oxidation state of hydrogen in lithium hydride? -1. Clear? Easy? Easy or not?
Yes, sir.
Now, next. Fourth rule. Fourth rule told us that of oxygen. Okay. Oxidation state of oxygen generally -2. Generally -2. Okay. But when oxygen attached with another oxygen with single bond, we call it peroxide. We call this peroxide. So when peroxide is there, each oxygen having oxidation state -1. Okay, each oxygen having oxidation state -1. And when superoxide is there, what is superoxide? I will tell you. Okay, when superoxide is there, then oxidation state will be -half. Clear? Oxidation state will be -half. Understood?
Yes.
Okay, so this is the fourth. Now, last rule is very simple rule. Last rule is like this: hydrogen, oxygen, first element, second group element, fluorine. This you understood, but unknown element you wanted to check. Okay, so to determine oxidation state of an element in a compound, you have to make linear equation. You have to make linear equation. Now, what is linear equation and what is this? Listen, for example, if I wanted to find out the oxidation state of manganese, in KMnO4. So how to find out? Understood. Let's say Km potassium. What is the oxidation state of potassium here? Already told, +1. And oxidation state of oxygen is -2. Let's say manganese oxidation state X. So how many potassium is there? 1 into +1. Okay. Plus how many manganese is there? 1. And what is the oxidation state? X. How many oxygen is there? 4. And what is the oxidation state? -2. Overall, any charge in this molecule? Is there any charge in this molecule? So no charge. So equal to 0. So from here, if you find out the value of X, X will be +7. So oxidation state of manganese in this compound will be +7. Understood?
Yes.
Understood how to calculate? So if I give you some compound, can you find out the oxidation state?
Yes, sir.
Okay, I'm giving you some compound. So let's find out oxidation state. First is K2Cr2O7, chromium. Second, H2SO4, sulfur. Third, ZnSO4, sulfur. Fourth, K2O, oxygen. Fifth, KO2, oxygen. Sixth, MnO, manganese. Seventh, carbon dioxide, carbon. Eighth, chromium trioxide, chromium. Ninth, HNO3, nitrogen. 10th, lithium aluminum hydride, aluminum. 11th, NaBH4, boron. 12th, C6H12O6, carbon. 13th, CrO5, chromium. Go ahead. So one more I'm giving, two more I'm giving. 14, OSO4, osmium. And 15, MnO4 minus, manganese. Go ahead. I'm giving you 5 minutes. 6 minutes I'm giving. Understood what I am asking?
Yes.
Tell. What is the first one?
-6.
Huh?
-6.
-6. How you are reading -6? Potassium plus 2. Potassium +1 is or no? And oxygen -2. So
+6.
2 into +1 plus 2x and plus 7 into -2 equal to 0. So x value will be +6. So answer will be +6. Clear? Don't be hurry. It should be correct. Okay, correct. Next, accuracy is more than your time. Go ahead. Next one.
+6.
Next one again +6. Next, ZnSO4.
7.
Sulfur. What is the value?
6.
6, not 6, +6. Okay. Clear? Zinc. What is zinc?
Yes, sir.
Zinc will be +2. Okay, remember zinc +2 and oxygen -2. Next, here oxygen -2. Okay, potassium +1. Here oxygen -half. So here oxygen in which condition? Superoxide condition. Clear? Next here, tell.
So +2.
Here +2.
+4, sir.
+4. Very good. Next here
+4
again +4. Here
+6, sir.
plus 6. Okay, next here
plus 5.
plus 5. Next here,
Minus
here minus.
5. Minus 5.
Okay, let's see. So lithium plus 1 and hydrogen minus 1. Yes or no? Yes or no? Aluminum is a metal, hydrogen attached to the metal. So 1 plus x minus 4 equal to 0. So x is equals to plus 3, not minus 3, plus 3. There. So this is known as lithium aluminum hydride, where hydrogen acts as an H minus. Next here,
Plus 5.
again same thing. Here also plus 3. Okay,
Oh,
here also plus 3, same only. Lithium aluminum hydride, sodium borohydride, same only. Clear? Here in glucose carbon,
0.
0. Very good. Next here,
10.
10 plus 10.
Yes.
Achha. Think about it. Plus 10 oxidation state possible.
No.
Can anyone give 10 electron? Not possible, right? So here what happened? You need to know the structure actually. Here the structure look like actually butterfly structure. Okay. Here the structure actually butterfly structure. Understood? So when you break, for example, before going to this, understood about carbon dioxide. Okay. If you break one bond, carbon will be plus 1 and oxygen minus 1. Another bond, carbon plus 1, oxygen minus 1. Yes or no? Similarly, if you break this two bond, oxygen minus 2, carbon plus 2. So that's why carbon oxidation state you got plus 4 and each oxidation state you got minus 2. Clear? Yes or no? Yes or no?
Can I explain once again, sir?
You break H bond, you put carbon plus 1 and oxygen minus 1. Yes or no? Because carbon less electronegative, oxygen more electronegative, minus 1 plus 1. So if I break 2 bond, carbon will be plus 2, oxygen will be minus 2. That's why oxidation state of oxygen came minus 2. Okay, and carbon dioxide, carbon oxidation state came plus 4. Yes or no?
Yes, sir.
Similarly, we'll break here. So what we will break? See, break one bond. So oxygen minus 1, chromium plus 1, another bond plus 1, minus 1, another bond minus 1, plus 1, another bond minus 1, plus 1. And if I break this two more, so minus 2 and plus 2. So overall oxidation state will be plus 6. Yes or no? So in CrO5, oxidation state of chromium is plus 6. Chromium can maximum show plus 6. Now you can see here, two peroxide bond is there. One peroxide bond and another peroxide bond is there. Yes or no? So peroxide, in case of peroxide, oxygen oxidation state minus 1 you can see. But normally oxidation state minus 2. So sometimes you need to know the structure of the compound. Sometimes you need to know the structure of the compound. Clear? Sometimes.
Yes, sir.
Other time you can make the formula, you will get. Okay. Now tell me next one.
Plus 8.
Here possible plus 8. Osmium, remember osmium is the only element who can show plus 8 oxidation state. Maximum shown by manganese plus 7. Here you can see manganese KMnO4 plus 7. Here MnO4 minus plus 7. Okay, clear or no?
Yes.
Clear this thing. Now coming back to here. Tell me, iron oxidation state 0. Yes or no?
Yes, sir.
Sulfur oxidation state 0.
0.
Here iron oxidation state plus 2 because sulfur will be minus 2. Yes or no?
Yes, sir.
So 0 to plus 2 oxidation or reduction?
Oxidation.
Oxidation, increase in oxidation state. And 0 to minus 2 reduction. Simply you can do. Yes or no? So any reaction you take, you can do by oxidation state method. Like here also, Copper here 0 and copper oxide here plus 2. So plus 2 to 0 reduction. Hydrogen 0 here hydrogen plus 1. Sorry, plus 1. So 0 to plus 1 oxidation. Understood this thing? Easy. So by oxidation state method, you don't need to check oxygen adding, hydrogen adding, or electron going or not. No. Direct find out oxidation state, you can do easily. Clear? Any doubt?
No, sir.
Clear or no? So now coming now one more reaction I'm telling. One more reaction tell, then we'll go for electrochemistry. Tell. Let's suppose I'm giving one reaction H2S plus Cl2 giving sulfur plus 2HCl. You have to tell me that which one oxidation reaction and which one is oxidizing agent and which one is reducing agent. Tell. Tell which one oxidizing agent and which one reducing agent.
Sir, H2S to 2HCl, it is reduction. Should we tell the reagent or the reactions, sir?
No, reactions also. Tell. So H2S2 sulfur is what?
Reduction.
Reduction. Reduction.
No, oxidation.
Oxidation. And chlorine to HCl is reduction. Yes or no?
Yes, sir.
Understood. So here minus 2 to 0 and here minus 1. Sorry, 0 to minus 1. Clear? Clear or no?
Yes,
One more thing remember. Let's suppose sodium, I told you this earlier, sodium to sodium plus. So what is the oxidation state here? Plus 1 and here 0. So how many electron changing here? 2 electron. Sorry, 1 electron. Clear? And
yes,
if I tell magnesium to a Mg2 plus. So how many electron will be there? 2 electron. Similarly, if I tell H2S to S. So how many electron H2S is taking? 2 electron. Yes or no? Because we are going for minus 2 to 2, minus 2 to 0. Understood this thing?
yes, sir.
Understood? So electron changes also you can understood. Okay, you need to understand this. Clear? Now,
Yes,
coming to electrochemistry. Electrochemistry. Now, electrochemistry, you can see this made up of two words, electro and chemistry. Okay. So electro means electricity. Electro means simply electricity. Okay. And chemistry means chemical. Right. So electricity means electrical energy. Right. Electricity means electrical energy. Okay. Electrical energy. And chemical means chemical energy. Yes or no? So in this chapter, what we are going to learn that how to convert electrical energy into chemical energy and how to convert chemical energy into electrical energy. Okay. In this chapter, electrochemistry is a branch actually. Okay. So in this chapter, we are going to learn about how to convert electrical energy. Like by electricity, we can do chemical reaction, or by chemical reaction, we can generate electricity. Okay, that thing we will learn in this chapter. Okay, so what is electrochemistry? It is a branch of chemistry where it is a branch of chemistry which deals with interconversion of electrical and chemical energy. Electrical and chemical energy. energy. Okay, and see, use something you need, like where to convert this. Okay, so some device we need to convert this. So that device known as electrochemical cell. Okay, device known as electrochemical cell. So the device used for this conversion, for this conversion is called electrochemical cell. Is called electrochemical cell. Clear? The electrochemical cell also two type. Simple thing. Why two type? Because one device will convert chemical energy to electrical energy. One device will convert electrical energy to chemical energy. So, so two type. One type is known as galvanic or voltaic cell. Galvanic or voltaic cell. Another known as electrolytic cell. Electrolytic cell. Galvanic or voltaic cell, and another one is electrolytic cell. So one by one, we need to understand what is galvanic cell, what is electrolytic cell. Okay, till now this understood? Any doubt?
Yes, sir.
Okay. So first is, what is galvanic cell? What is galvanic cell? Understood what is galvanic cell? Galvanic means this is a device which is used to convert chemical energy into electrical energy. Okay, galvanic cell or voltaic cell. Voltaic cell. What? It is a device. This is a device which is used to convert, which is used to convert chemical energy, to electrical energy. Misunderstood? By chemical reaction, we can generate electricity. Okay, this kind of device. And what about electrolytic cell? Electrolytic cell. Exactly opposite will go. Yes or no? By electricity, we will do reaction. So this is a device. This is a device which is used to convert electrical energy electrical energy to chemical energy. Okay, clear? Or electrical energy to chemical energy. Or you can write that this is a device used to derive a chemical reaction which is non-spontaneous. Non-spontaneous means like not possible by passing electricity through it. Okay, here. Or you can write that where a chemical reaction to derive a chemical reaction by passing electricity through it. Electricity through it. Understood this thing? Any doubt? So chemical reaction means which kind of chemical reaction? Non-spontaneous. Non-spontaneous. For example, if I tell you water, you have to make hydrogen plus oxygen. You have to break water into hydrogen plus oxygen. Normally it is not possible, right? You give heat, you give light, not possible. But if you give electricity, instantly it will break into hydrogen and oxygen. Okay, so this kind of power having electricity. Understood?
Yes, sir.
Clear? Now listen. Now there is an observation I'm telling you. Let's suppose you are taking one beaker. Can you see the beaker here?
Yes, sir.
Okay. Let's suppose this this liquid here. This liquid is nothing but copper sulfate. Copper sulfate, blue color liquid. Okay, this liquid nothing but copper sulfate. So copper sulfate means in this liquid copper 2 plus is there and SO4 2 minus is there. Yes or no? Okay, copper sulfate, blue color liquid. Now what will happen if I put zinc rod in it? So I put zinc rod. I put zinc rod in it. So what happened after some time? So zinc rod is act as an electrode over here. Okay, act as an electrode. What will happen after some time? You will see this color, this blue color. Okay, this blue color become colorless. This blue color become colorless. Okay, not white. I'm just drawing white. So this blue color after zinc rod dipped here, this blue color become colorless. Understood? Okay. And one more thing, in the side of this zinc rod, in the side of this zinc rod, you will see some reddish brown color substance. Now what happened here? What happened here actually? Understood? Here zinc, we are taking zinc solid. Yes or no? Zinc solid. So what will happen? Zinc becomes zinc 2 plus and gives 2 electron. What kind of reaction this is? Oxidation or reduction?
Oxidation.
Oxidation. Again simple. Oil rig. Oil rig. Oxidation involves loss of electron and reduction involves gain of electron. So loss of electron, that means oxidation. And copper is in copper 2 plus, right? So copper 2 plus, which is in aqueous state, take this two electron and become copper. See this brown color substance you are seeing, this is copper. Okay, copper metal, nothing. Understood? So this reaction is reduction reaction. So what is the overall reaction here? What is the overall reaction here? Zinc plus copper 2 plus will give zinc 2 plus copper. Yes or no? Now copper 2 plus color is blue, but zinc 2 plus color is colorless. Understood? Understood
Yes.
this? Now problem is where, sir, this thing okay, but same thing when I am doing reversal. Same thing when I am going to do reversal. Like I am taking, sir, zinc sulfate. I am taking zinc sulfate, which is colorless, and I am adding copper rod here. I am adding copper rod here. Okay, I am adding copper rod here. So here what I took, zinc sulfate, and what is this? Copper rod. Then also some change will be there. But after some time, we are seeing that no change. No change. Understood? There is an observation that no change is there. That means copper plus zinc 2 plus, no reaction. No reaction. Now why happened? Why this happened? When zinc we dipped in copper sulfate, it is reacting. But when copper sulfate, when copper dipped in zinc sulfate, it is not reacting. Why this is happening? Clear? We need to understand this thing. So that is why we are going to learn this electrochemistry. Okay, we are going to learn one by one step, one by one thing. Then you will understand why it is giving an. Okay. So first thing we are going to learn one thing that is called electrode potential. Called electrode potential. Electrode potential. Now what is electrode potential? Simply remember, it is the potential difference. It is the potential difference developed developed between electrode between electrode and electrolyte and electrolyte between electrode and electrolyte when an electrode is immersed in it. When an electrode is immersed in its electrolyte solution. Okay, is immersed in its electrolyte solution. So what does it mean? Understood this thing. Let's suppose I'm taking a zinc sulfate solution. Okay, I'm taking a zinc sulfate solution. So this is zinc sulfate solution. Okay, and I'm dipping. Listen carefully. I'm dipping a rod, zinc rod here. I'm dipping a zinc rod here. Understood? Hello. I'm dipping a
Yes, sir.
zinc rod here. So what is this? This is zinc rod. And what is this? This is ZnSO4 solution. Now ZnSO4 means there should be zinc 2 plus is there. Understood? Now zinc 2 plus is charged, yes or no? And zinc is neutral, yes or no? So from a charged particle and for a neutral particle, there should be some charge differences there. Now charge difference means there should be a voltage difference or potential difference should be there, yes or no? There should be
Yes.
a voltage difference or potential difference should be there. That difference known as the electrode potential. That difference known as the electrode potential. Understood? Understood
Yes.
this thing? Yes or no? Similarly, copper 2 plus and copper, between copper 2 plus and copper, some electrode potential will be there. Yes or no?
Yes, sir.
Now, how there are two type of electrode potential. You need to understand. One is called oxidation potential. One is called oxidation potential. Okay.
Sir, I think the screen got stuck.
Now, wait. Coming to oxidation potential. Remember, if potential difference develop due to oxidation, develop due to oxidation, due to oxidation. Okay. If electrode potential develop due to oxidation called oxidation potential. Called oxidation potential. Clear? For example, here we are taking zinc. Zinc solid become Zn2 plus. Yes or no? Plus 2 electron. So this is oxidation. Yes or no? And how to write?
Yes.
So for this reaction, what is the electrode potential of zinc? How to write? Understood. Electrode potential denoted as E. E naught. Okay, E naught actually standard electron potential. We'll talk about it. What is standard? So E naught. What is the reaction here? Listen. Zinc to zinc 2 plus. Clear? Zinc to zinc 2 plus. Understood? How to write? E naught, zinc, one line. One line means zinc to zinc 2 plus. Clear? See, whenever this is written, you need to understand the reaction is going on zinc to zinc 2 plus. Means what reaction? Oxidation or reduction? Oxidation. So oxidation potential and the value will be 0.76 volt. Clear?
Yes, sir.
Value will be
So
0.76
for all oxidation 0.32, for zinc
for
oxidation
zinc only. For zinc. Okay. Zinc
Okay.
only 0.76 volt. Clear? So this is oxidation potential. How to write? Understood? Next,
Yes, sir.
what is the reduction potential? Reduction potential means what is reduction potential? Reduction potential means same. If potential difference developed due to reduction is called reduction. Okay, developed due to reduction called reduction potential. Understood? Called reduction potential. For example, you take copper 2 plus aqueous and it is become copper plus 2 electron. Sorry, copper 2 plus 2 electron giving copper. So this is reduction. How to write this? See, E naught, what is there? Copper 2 plus, copper 2 plus 2 copper. So that is reduction is equals to 0.34 volt. Okay, well, like this we are writing this. Understood this thing? Yes or no?
Yes.
Okay. Now, one more thing, remember, E oxidation will be negative of E reduction. Understood? That means if I wanted to write the electrode potential, reduction electron potential of zinc, then what? How to write? E naught zinc 2 plus to zinc. Yes or no? So what will be the value? Minus 0.76. Understood? Or oxidation
Yes.
potential of copper, then what will be the value? Minus 0.34. Clear?
Yes, sir.
Understood this thing? Any doubt? Oxidation potential, reduction potential.
No, sir.
Now coming to galvanic cell.
100, sir.
No, no.
So it cannot be slanting lines, no, sir, for that,
Sorry.
for representing the self representation of that cell potential, that is, it cannot be a slanting line, no, sir.
Slanting line means
Slanting line means like this.
like this.
Slash.
You can put,
Yes.
see, Zn2 plus like this you can put, or Zn2 plus like this you can put. Same thing. Both are same. Okay. If you
Okay.
check your computer keyboard, both are in the same key. Right.
Yes, sir.
Okay. Should we go further? Survey understood? Tell me. You're not responding.
Yes, sir.
Respond. Otherwise, I'm not getting that you understood or not. Clear?
Done, sir.
Okay. Listen. Now, understood. Galvanic cell. Very important. So, one type of cell I told, galvanic cell or voltaic cell. What is galvanic cell? That by this cell, we will convert chemical energy to electrical energy. Okay. By this cell, we will convert chemical energy to electrical energy. Okay. Now listen one by one. Okay. First understood what is galvanic cell. So in this compound, in this whole setup, what is this? One by one understood. So this is ZnSO4 solution. This is an electrolyte solution, ZnSO4. So ZnSO4 means inside Zn2 plus is there and SO4 2 minus is there. Yes or no? Zn2 plus and SO4 2 minus is there. And what is
Yes,
this?
sir.
This electrode? Zn, zinc electrode. Similarly, this is copper electrode. Okay. Actually, this particular cell known as Daniel cell. Okay. This particular cell known as Daniel cell, which is an example of galvanic cell. Okay. So copper, and this solution is copper sulfate solution. copper sulfate solution. So that means here copper 2 plus is there. Okay, that means here copper 2 plus in SO2 minus. Now what happened? Understood this thing. What will happen? So this side, and very carefully understood. This side, our solution is there. Okay, this side also our solution is there. Now this electrode zinc is neutral. Now this Zn2 plus will come. Zn2 plus will come closer to this electrode. Yes or no? Zn2 plus will come closer to this electrode. So there
Yes,
will be a developing electrode potential. Yes or no? It will develop an electrode potential. Similarly, here also some electrode potential is there. Remember, to conduct electricity, to pass electricity, two things we need. To conduct electricity, we need two things. One is, what is the first thing? Do you know? What is the first thing? Any idea? To conduct electricity, we need two things. Remember, first is potential difference. First is potential difference. And second thing, that your circuit should be completed. Complete circuit. Clear? One is potential difference, one is circuit should be complete. Now here some different potential, some it has some electrode potential. Yes or no? It has some electrode potential, E naught value, and it has also some electrode potential, E naught value. So because of that, now we have to check which have more and all the things. Because of that, electron should pass. Yes or no? Because of that, electricity will go. Some potential differences there. Yes or no? Yes or no?
yes,
So our observation is there is a key, there is a switch is there. When you plug on this switch, this light, this is a light, this bulb, this bulb will glow. Okay, this happening. Okay, this you can try in home also. Okay, so this light will glow. Understood? That means by the chemical reaction, we are generating electricity. By the chemical reaction, we are generating electricity. Now, what happening here actually? What happening here? Here zinc rod is there. Zinc in the left side. In the left side, what is happening here? Zinc. Zinc solid becomes Zn2 plus and gives 2 electron. Okay. Zinc solid becomes Zn2 plus and gives 2 electron and having oxidation. So zinc giving 2 electron. This 2 electron will go this side. Go by this wire and come to this wire and it mix with copper 2 plus. So when it mix with copper 2 plus, copper 2 plus will take this 2 electron and become copper. Clear? Copper 2 plus will take this 2 electron and become copper. So this transition happened, and the pathway of electron which side, the electricity pathway always the back side is on opposite side. You learn in electricity chapter that which side electron going, electricity will go opposite side. Okay, so electricity will go opposite side. Understood this thing? Yes or no?
yes, sir.
Okay, and also when you calculate the voltage difference showing 1.1 volt. Voltage difference showing 1.1 volt. Now there should be a voltage difference. Now listen one thing, one by one. So here oxidation happening, here reduction happening. Acha, where the number of electron, which electrode having more electron density? Which electrode? Zinc or copper?
Copper,
Copper. Where electrons are coming from which side? Zinc. So zinc can be considered as negatively charged, yes or no? Zinc can be considered as negatively charged, and copper can be considered as positively charged, yes or no? Well,
yes,
electrons coming where which side known as negatively charged, and electrons coming where it is known as positively charged, and that's why zinc here oxidation happening. That's why it is known as zinc electrode known as anode, and where reduction happening, that electrode known as cathode. So two type of electrodes are there. One is anode, one is cathode. Remember, anode means oxidation, cathode means reduction. Doesn't matter what charge is there. Okay, doesn't matter what charge is there. Where reduction happening, we call them cathode. Where oxidation happening, we call them anode. Remember, I'm giving you a mnemonic: red cat, and ox. Okay, red cat means reduction happening in cathode and anode happening oxidation. Remember this thing. Charge doesn't matter. Clear? We'll learn electrolytic cell later on. Their charge will be different. But like here, anode, what is the charge of anode here? Negative. And what is the charge of cathode here? Positive. But in electrolytic cell, it will be reverse. But this concept will be same. Anode means oxidation should be there, and cathode means reduction should be there. Clear or not? Tell.
Yes.
Okay. So what is anode? Anode means oxidation. In this case, negatively charged. Okay. Or source of electron. Source of electron. Okay. And here, reduction means consumptions of electron. Consumes electron. Cathode consumes electron. Okay. Understood? Yes or no?
Yes.
Now, problem is there when we do this thing now, instantly within 2 seconds, this light bulb stops. This light bulb stops, and this voltage showing 0 volt. Voltage showing 0 volt. What happening? This all the electrons coming here, okay, and it is neutralized copper 2 plus. So when neutralized, the electrical neutrality is there. So when electrical neutrality is there, no potential difference, no electricity passing. That's why we have to add this thing. What is this? This is known as salt bridge. This is known as salt bridge. Okay, this is known as salt bridge. Now, sir, what is salt bridge? So write down what is salt bridge. Salt bridge, by the name you understood it should contain some salt or something, right? So it is a U-shape. It is a U-shaped tube containing an electrolyte jelly. Okay, tube containing an electrolyte. Okay, containing an electrolyte and outer surface containing a jelly, okay, a jelly or agar-agar form, okay, or agar-agar form, okay, agar-agar form. Like this is, listen this thing. This is a salt bridge, okay. Inside some electrolytes are there. Inside some electrolytes are there. What electrolytes are there inside? Okay, what electrolyte? KCl can be there. NH4NO3 can be there. Okay, NH4 whole 2, SO4, SO4 can be there. KNO3 can be there. So this kind of salts can be there. Okay, inside. And outside some gel, agar-agar gel is there. Outside some gel is there. Okay.
So what is agar-agar?
One kind of gel. Okay, one kind of, one kind of gel, you like, it will one kind hygroscopic gel. Okay, hygroscopic gel means, sorry, hydrophobic gels means water. It will reflect water from it. Okay, so there are like, why we use this salt bridge? What are the significance of salt bridge? I'll tell. First of all, understood why we use electrolyte. Because if you use electrolyte, whenever here electrical neutrality happens, the one of the ion, let's suppose KCl you are using, K plus Cl minus. So Cl minus will go there and again it will change its electrical neutrality. Understood? So again potential difference will form. And why we are using agar-agar gel? Because sometimes what happens, this SO4 or CO2 will go inside and come there this side. Yes or no? So to prevent the electrolyte going from one side to another side, we use agar-agar gel. Understood this thing? Yes or no?
Yes, sir.
See, I'm telling you, simple chemistry. See, after some time, zinc is there. So zinc is giving 2 electrons. So after some time, it will get destroyed. Yes or no? After some time, it will get destroyed. And copper become too much big. Yes or no? That's why this cell, the light getting stopped. So to prevent this thing, we are using salt bridge. Understood? Now, who can be salt bridge? Condition for salt bridge, sometimes question asks that what are the condition?
So if salt bridge is there, what will happen? The light will always glow up.
Light will glow. No problem.
How?
What how? Potential difference always be there. No potential difference will not become zero. Yeah.
Between the two electrodes, sir.
See, circuit completed na? Yes or no? Circuit completed. Potential difference always be there. Always be there. So electricity will pass. Always. Not always. Actually, sometimes after you will see that when electricity, all the nuclear like zinc will getting destroyed little bit, then it will stop. Okay, not every time. Then we'll get all time energy. Not like that. Clear?
Yes, sir.
Clear or not? Understood this thing?
Yes.
Now, now what are the conditions? First condition is that ionic mobility of cation and anion should be same. Whatever we are using electrolyte, that ionic mobility of cation and anion should be same. Clear? Ionic mobility of cation and anion should be same. Next, electrolyte, what we are using, electrolyte should be used should be inert with respect to ions present in cathode and anode. With respect to ions present in cathode and anode. Means if you are using a zinc 2 plus ZnSO4 and copper 2 plus, you should not use that electrolytes. Clear? Understood this thing? Present in cathode and anode. Clear? So what electrolytes we are generally using? Already I told KCl, KNO3, okay, NH4NO3 or NH4 whole 2 SO4. This kind of electrolytes we are using generally. Clear? Any of them? Understood?
Yes.
Next, what is the function of salt bridge? Function of salt bridge. Remember, first function is circuit completed. It completes the internal circuit. It completes the internal circuit. And second, it maintains electrical neutrality. It maintains electrical neutrality. And salt bridge minimize liquid junction potential. Now what is the liquid junction potential? Liquid junction potential means, understood this thing. What is LGP? What is liquid junction potential? Liquid junction potential means, see, here this liquid is there, it has Zn2 plus, it has some potential, and copper 2 plus had some potential. Because of this potential, this become too much big, like here when zinc 2 plus will come to the electrode and copper 2 plus will come to the electrode, okay, they will have their own potentials. So this junction potentials are known as liquid junction potential, and when you use salt bridge, they will not come around too much. So they will like decrease the liquid junction of potential or minimize the liquid junction potential. Yeah.
Last few lines around it.
Huh? Tell.
Last few statements that you told, I didn't understand.
Liquid junction potential. Actually, you don't need to understood what is liquid junction potential. It's not you having. Just remember this thing. Sometimes question asks what is the function of salt bridge. You need to write liquid junction. Liquid junction potential means understood. See, this is their electrode, and this is electrolytes are there. Okay, so when some electrolytes comes close to this electrode, okay, come close to this electrode, so some potential will develop. Here potential will develop, it will not give electrons outside or not take electron from outside. Understood? So to minimize this potential, we use salt bridge. So when salt bridge is there, they will remove this ions from it. They will throw these ions little bit far away, and their potential will minimize, and then electrons movement will be there. Clear?
Yes, sir.
Okay. Understood? Any doubt? Anyone? Sarvesh? Now, last topic we will learn today, that is how to represent cell. Galvanic cell representation. Galvanic cell representation. Representation. So there are certain rules. One by one I am writing. Remember. Okay. First rule is anode. Anode is written in the left. Anode written in left side. Left side. And cathode written in right side. Cathode written in the right side. Clear? So in this reaction, what is happening? Anode, in the anode side, what is happening here? Tell. Zinc becomes zinc plus, yes or no? Zinc becomes zinc 2 plus. Okay. So that anode reaction we will write first. Okay. So anode reaction is zinc solid with one line. Electrode first, then it is becoming zinc 2 plus. Okay. Aqueous. So this is anode equation. This is anode equation. Here. Yes or no?
Yes, sir.
So what is the second point? That single line represent, okay, represent phase separation. Phase separation. Phase separation between electrode and electrolyte. Electrode and electrolyte. Clear? Yes or no? And when you are writing electrolyte, also you have to write the concentration also in bracket. You have to write the concentration or the pressure, how much pressure it is, what you are having, that you have to write. Clear?
Yes,
Next,
sir.
after that, what is there? Salt bridge is there. So to represent salt bridge, we are using double line. To represent salt bridge, we are using double line. Okay. So third point, double line represent salt bridge. Sometimes salt bridge is not there, so no need to represent. Okay. Okay. Here.
Yes, sir.
Next. So right side, who will come? Cathode. So in the cathode, what is the reaction? Copper 2 plus aqueous 2 copper. See, when you see a cell, this is written in a cell. Nothing, no reaction written, nothing written. This is written in a cell, and when you are writing this, there also you have to write the concentration. Clear? Clear or no?
Yes, sir.
Okay. And also I, I told that electrodes written in extreme left, which is anode, and extreme right, which is cathode. Clear? Extreme right, which is cathode. Clear this thing? Yes or no? Now understood. Very,
Yes.
very important thing. What you have to do, that is I am telling. See, by this representation, you should know how to write equation, reactions. Okay. For example, representation given like this. Representation given like this. That zinc 2 plus aqueous solid bridge Fe3 plus aqueous dot Fe2 plus aqueous platinum solid. Now how to write? So first you have to write anode reaction. First you have to write anode reaction. Remember, one more I am telling, one more mnemonic I am telling. Lone. Lone. Lone means left side. O means oxidation. A means oxidation happening in anode, and N means negatively charged. So anode always having oxidation. It should be in left side, and it should be negative charge for galvanic cell. So left side, which is there, anode. Anode means oxidation happening. What is there? Zinc 2, zinc 2 plus 2 electron. And this side cathode, yes or no? So in the cathode, what is happening? Cathode reaction, what is the cathode reaction? Reduction. So reduction, what is happening? Fe3 plus, Fe3 plus 2, Fe2 plus. Here, how much electron it will take? Tell, how much electron it will take?
Left hand side, 1 electron.
1 electron it will take. Now, see, it is taking 2 electron. But here 1 electron, so we have to multiply with 2. So overall equation if you write, so what you will get? Zinc plus 2 Fe3 plus will give zinc 2 plus Fe2 plus. Yes or no? Understood?
Sir,
Understood? Yes or no?
yes.
So any equation given, can you write down the any equation given? Can you write down the reaction?
Yes.
Okay. Now you will tell, sir, what is platinum? Platinum is known as inert electrode. Inert electrode. Remember this thing also important. What is platinum? Platinum is known as inert electrode. See, it will not participate in reaction. Okay. It will not participate in reaction. They are used only to flow of electron. Understood? They use only to flow of electron. Okay. Inert electron means they don't participate in reaction. Participate in reaction. They use only for flowing of electron. Only for flowing of electron. Clear this thing? Understood? Hello?
Yes, sir.
Now, yes, I'm writing one question. Just you have to tell the reaction, overall reaction, anode reaction, cathode reaction, overall. So, electrode given. Go ahead.
Sir, is it copper plus 2 Cl minus gives CO2 plus Cl2 plus 4 electron?
Right? One by one write down. So this is anode, right? Yes or no? So what is the anode reaction here? Copper will give copper 2 plus 2 electron. Yes or no? Yes or no? Tell.
Yes, sir.
And this is anode. So anode is what is anode doing? That what is anode doing? Tell.
Cl minus gives Cl2.
Cl minus. Cl minus. Cl minus will give Cl2.
That is after balancing, that is 2 Cl minus gives Cl2 plus 2 electrons.
Wrong answer. Listen, Cl2 will take 2 electron and gives Cl minus. Understood this thing? Cl2 will take 2 electrons and gives Cl minus. That is the thing that you need to understand. Okay. Cathode. Cathode means reduction will happen. Whatever written here doesn't matter. Reduction will be happen, right? Yes or no?
Yes, sir.
So reduction means what? Chlorine to Cl minus, yes or no? This is reduction, 0 and -1. Reduction. Yeah, that's why I'm telling oxidation reduction is very important for this chapter. Okay. So overall equation will be, now you have to balance this. Okay. You have to balance this. So how to balance? This 2 Cl minus will come. So what will be the overall equation? Copper plus Cl2. Actually, copper is solid. Cl2 is gaseous. And it will give copper 2 plus aqueous and plus 2 Cl minus aqueous. How it's looking? Like how this shell actually be? See, this is one cell. This is one cell. Okay. And you are adding here copper 2 plus is there and here Cl minus is there. Okay. And here copper is there. Here platinum electrode is there. Platinum. And we are adding with this. Understood? And what happened? Here I am filling with chlorine gas. Okay, I am adding chlorine gas from outside. And here I put a bulb and then salt bridge you add, whatever salt bridge you are adding. Okay. So then the bulb will glow. Clear? Understood this thing? So by seeing a cell representation, how to write reaction, or by a whole reaction, how to write cell representation. Understood? Whenever a whole reaction given, first find out oxidation, then find out reduction, then write this. Clear this thing? Both thing important. By seeing cell reaction, how to write representation. By representation, how to write reaction. Clear?
Yes, sir.
Okay, next day we will learn measurement of electrode potential. How to measure electrode potential. Okay, any doubt?